Hello students, welcome to Dr. Shora's classes. So in this particular video, we'll be looking into the sum from AP calculus. This is the advanced placement calculus BC part, and it is composed of the free response question. So we will solve some mathematical problem. So first let's understand what this free response question are. Okay. So what are these free response questions? So in short we can say that is FRQ. So in this advanced placement exam, so this part is the most significant part, and this particular section can affect your overall score, and it is also one of the most challenging section. So these are this free response question. So how to handle this particular part, and if you people are more concerned about your performance on this particular portion of this advanced placement, so we will follow a 5-step strategy to cope with this, and so that we can perform well in this particular section of advanced placement. So first we have to understand what the question is saying, right? So the thing is that read carefully. This is the 5-step process to get a good performance in this particular section. So next is you often see that this free response question consists of the multiple parts, so we have to maximize the points in this multiple part questions. Next is you have to share your thought process. In case of other essay type question, you have to share your thought process, and you must be clear and concise what you are mentioning in the paper. Your concept should be clear. And the last one is the usage of the proper penmanship. Okay. Okay, so these are the 5-step strategy. If you follow this, then we can easily get an upper hand on this particular section. Now, so as you can see that this AP calculus question consists of several parts. So we will solve each part of the question one by one. We will check with that. Okay. So there are 4 multi-part questions, A, B, C, D of this particular question. So let's move to this question 1. Question 1 is saying that the density of a bacteria population in a circular petri dish at a distance r centimeters from the center of the dish is given by an increasing differentiable function f, where fr is measured in milligrams per square centimeter. Okay, so it is milligram per square centimeter. So values of fr for selected values of r are given in the table above. You can see. So this is the particular table. It is given for r in centimeter of the radius of the petri dish with a particular function, increasing differentiable function. You can see is a increasing differentiable function f. So this is the question number 1, and we have 9 points, 4 parts to this question, A, B, C, D. So we will solve one by one. So let's check the first question, this part A. Use the data in the table to estimate f prime 2.25. Using correct units, you have to interpret the meaning of your answer in the context of this problem, right? So first here it is we have to estimate. Okay, so we have to estimate the value of f prime 2.25. Okay, so how to find? So we have the value of 2 and 2.5. So we will write f of 2.5 minus f of 2 divided by 2.5 minus 2. So f of 2.5 is 10, so it is minus, f of 2 is 6, so it is 2.5 minus 2 is 0.5, so here we will get 8. So this is the value. We have estimated the value 8. Now in the second, what is given? That use correct units, interpret the meaning of your answer in the context of this problem. Okay. So you're interpreting. So you can say it is distance of 2.25. So we can write in this. So at a distance of r equal to 2.25 centimeters from the center of the petri dish, okay, the density of the bacteria population is increasing at a rate of 8 milligrams. We have to write in full sentence per square centimeter per centimeter. So this is the total interpretation of the for part A. So for this estimation part, okay, you have find the value of 8. So this is 1 point, right? And you have interpreted the result with units, milligram per square centimeter per centimeter. So for this 1 point. So in the part A we have cumulative 2 points. Okay. So now let's go to the part B. So part B is saying that the total mass in milligrams of bacteria in the petri dish is given by the integral expression 2 pi integral 0 to 4 r of f r dr. So what we have to find, the approximate the value of 2 pi of this particular integral function using a right Riemann sum with the 4 sub intervals indicated by the data in the table. So in that case we have to follow to the table first. Okay, 0 1 2 to 2 2.5 and 4. So 0 1 to 6 10 and 18 of the value. Okay, so let's solve this. So first we have to set up the right Riemann sum. So the integral is 2 pi 0 to 4 r of f r dr. Okay, so from here we can this 4 sub intervals 2 pi 1 dot f1 1 minus 0 plus 2 f2 2 minus 1 plus 2.5 f of 2.5 2.5 minus 2 plus 4 f4 4 minus 2.5, sorry, so it will be 4 minus 2.5. So let's put the value over here. So this is the right Riemann set. Okay, now next we have to approximation. So this is the right Riemann setup. So next we have to find the approximation. So this 2 pi is given 2 pi as it is. So 1.2.1, putting the values over here, 2.6.1 plus 2.2.5, it will be dot 10 multiplied by 10 multiplied by 0.5 plus 4.18 dot is multiplied by 1.5, right? So if we solve this, it will come as 269 pi, and the result will be, put the value of pi over here, it will become about 845.088. so you can use your graphing calculators over here to find the value. So here you can see that for the first part, this right Riemann setup, we have this is 1 point, and for the approximation we have find the value, so this will be of 1 point. So here we have total 2 points for part B. Now let's check with the part C. So it is asking, is the approximation found in part B, that is approximation value we have found, an overestimate or underestimate of the total mass of bacteria in the petri dish? Explain your reasoning, right? So for the first case, for the first part, we have to find whether it is a overestimate or underestimate. So for that, we know that the product rule for the expression, if we write this of DDR of R and FR function. So what it will be? It will be written, it can be written as, so it will be the f of R plus R f prime R, right? Now here you can see that for the explanation part, so in this particular problem you can see that the function f is non-negative and as well as increasing, right? So similarly, this ddr of R of fr function, which is greater than 0 on the interval, so interval in the interval 0 less than equal to R less than equal to 4, right? So the integral R of fr is strictly increasing, right? So from here we can say that the right Riemann some approximation of the integral, that is 2 pi 0 to 4 R of fr dr, is an overestimate. Okay, so here we can see that the first you have given the product rule for expression, so this is the 1 point, and in case of the explanation, so in this manner you have to explain the answer to get the marks, and here it is will be 1 point. So for the part C we have the total 2 points. Okay, so along with this I am also giving the idea of how to particularly get the scoring marks over here, how to express your answer. Okay, now let's move to the last part, that is D. So part D, the density of bacteria in the petri dish for this particular interval is modeled by a function g, which is defined by gr 2 minus 16 cos of 1.57 root r over to this 3. So you have to find what, for what value of k in the particular interval gk is equal to the average value of gr on the interval, the same interval that r is greater than equal to 1 and less than equal to 4, right? So for this case we have to find first of all the average value. Okay, so first is the finding of the average value, that is g of average, which is 1 by 4 minus 1 integral 1 to 4 g of r dr. Okay, so that is a definite integral. So we have to find the value over here, so we can easily find the value of this particular integral, that is 1 by 3 integral 1 by 4. You can just directly put the value of gr and use your graphing calculator. You will find the value as 9.875795. Okay, and we have to find the value of k from here, right? So for what value of the k? So gk is g of k is equal to this g average when k is equal to 2.497. So for this presentation of this numerical value, so here just let's understand the point, the scoring point. So first you have to find the average value, what is the definite integral you show, so that carries a 1 point. And in the second case, as the presentation of the numerical value, but of this particular numerical value, it is not required to earn the second point. The point can be earned by this particular, the average value setup that we have given over here. It can be performed using your calculator. So that is the 1 point. And for the next one, the finding the value of the k, so we will get this 1 point. So in this part we have the total 3 points. Okay, so that's all for this question 1.